to enhanced GPU infrastructure solutions with Oracle and Avacia. We will be covering a quick demo about Avacia's Elastic GPU Service, also called EGS. EGS enables enterprises to share and better utilize their GPU inventory securely among multiple teams of developers and data scientists. Key features of EGS are cost management, observability, multi-tenancy backed by RBAC, and dynamic and prioritized fractional as well as full GPU sharing between teams of engineers, developers, and data scientists in an enterprise. As part of the demo, we will cover the administrative features that EGS offers and cover how it is easy to add inventory of GPUs available to be shared between the different teams. How to create teams, how to provide users access and make them part of these teams, how to manage resource and costs for the teams that are using the inventory of GPUs, how to get continuous monitoring and deep observability of what's happening on the GPUs across the AI workloads from the different teams, as well as queue management. So let's take a quick look. Once the user is created, they can be associated with role-based access that can now give them access to their workspace. So for example, we'll be using the RAG Dev Teams credentials, tokens, to log into the EGS platform as a user. And let's see what the user is able to do once they get access to the platform and the resources associated to the platform with the GPUs. So logging in using the RAG Dev Teams credentials, the user is able to get the following features. A quick summary of the features available to the user when they log in to the platform. Users are able to request for GPUs to use for their AI workloads. Users are able to look at inventory that's available on the platform. Users will be able to have a deep observability into the AI workloads that they are running. Users will be also able to create tokens to use APIs and SDKs to interact with the platform. And users will be able to do queue management for the AI workloads that they own. Now let's take a quick look at what's possible through the UI. As a user that needs to run AI workloads on GPUs, the first thing to do is to request for GPUs for the workloads that they plan on running in the namespace associated to their GPU workspace. Doing that is fairly easy. Give the request a name. Pick the available node types that is compatible with the workload that the user needs to run. Basically request for the total duration for which this workload would be running. In my case, I'll be using 30 minutes as an example. Be able to estimate how quickly this the workspace can be available with GPUs. It so happens that there is availability right now, so we will go ahead and request GPUs for this workload. And as you can see, the user currently has a history of GPU requests that have been made. Majority of them have been completed. Some have failed. One is currently provisioning and running, and another job that we just kicked off is in queuing state. Now let's look at the AI workloads that are currently running in this GPU workspace for this particular user. So there is one existing workload that's running. And as a user, you are able to look at the details of that model workload as pods, as GPUs, and also be able to track how the workload is doing with respect to progress, temperature, power, memory, and GPU utilizations. So for this particular workload, there's a single GPU that's running and associated with the actual physical GPUs in which the pod is attached to. Being able to observe not just where the GPU is running, what the state of the temperature, power, memory, GPU utilization is, but also being able to look into how the workload is operating or performing at the infrastructure layer as well. So now let's look at also how the user can also manage API tokens that they can use to use the SDK or API towards the platform. And also see what inventory is available and used on the platform. So that gives you a quick view of what the end users or developers and data scientists are able to use the EGS platform to get access to GPUs in a shared format. So last step, we'll go back and look at the admin portion of the platform. So we've covered adding inventory, we've added creating teams, creating users, providing them access to the platform so that the users get access to the GPUs to run their workloads. Now let's go back to the admin view and look at resource and cost management, continuous management, and deep observability that the platform provides for the admins across the entire footprint of the GPU inventory, as well as queue management functionality. So going back to the admin view, as an admin, you're able to monitor all the GPU requests across all the slices, basically all the teams that have access to using the inventory of GPUs that are managed by the platform. And you're also able to look at GPU requests for the individual slices or the individual teams. And as we've seen, we have one that's in queued and one that's in provision for the RAG dev team. In addition, you're also able to take an existing workload and be able to kind of manage the queue and also looking at the cost management and resource allocation for the individual team for their GPU workspaces, being able to associate soft and hard limits on usage of the resources to monitor and track the same usage in terms of cost management. So real-time tracking and visibility into costs for each team is a key differentiator for this product. In this case, you can see that all the different workloads run by this team and the costs associated to running these workloads in real time, as well as deep insights into how the platform is performing across the teams and across the clusters. So that's a quick summary of the EGS platform and how it helps enterprises more effectively use the GPUs and manage them in real time, effectively improving the utilization of the GPUs and also giving the enterprise users an easy and efficient way to access GPU resources and utilize them effectively. We are excited to work with Oracle to present EGS as part of their superior world-class GPU cloud, bringing enterprises increased node allocation by 44%, reduced GPU wait times by 32%, increasing 44% more workload minutes on the infrastructure, and 100% data sovereignty. Thank you.